Worksheet 4.9 Quadratic Functions. So here for part 1 we're going to graph the following parabolas using a table of values. So first of all we've created our table of values or our tables here, and we can enter our values in. So here 2 times negative 2 squared gives us 8, and we fill in the rest 2, 0, 2, 8. So now we see we have our x and our y. Our y needs to go at least as high as 8. It's going to be hard to draw on this one, but 1, 2, 3, 4, 5, 6, 7, 8. And here our x1, 2, 1, 2 here. So here when x is minus 2, minus 1, minus 2, y is equal to 8. When x is minus 1, y is equal to 2. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 8 here. And so we can join our dots and draw in our parabola. So for our second equation here, we fill in our values here. We're going to get minus 2, 1, 2, 1, minus 2. So we see we can fill in, well, minus 1, minus 2, 1, 2 on our x-axis, and our y-axis we're going to be using the same range, aren't we? 1, 2, minus 1, minus 2. So when x is minus 2, y is minus 2. When x is minus 1, y is equal to 1. When x is 0, y is 2. When x is 1, y is 1. When x is 2, y is minus 2. So we join our dots and connect to form our curve or our parabola there. This is our curve, our parabola. Y is equal to minus x squared plus 2. Okay, so continuing on here. Y is equal to x squared plus 2x minus 3. If we fill in our table of values here, we have minus 3, minus 4, minus 3, 0, 5. So here we know our y needs to go at least to minus 4 and up to 5 here. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5, 1, 2, 3, and minus 1, minus 2 here. So when x is minus 2, y is minus 3. When x is minus 1, y is minus 4. When x is 0, y is minus 3. X is 1, y is 0. When x is 2, y is 5. So we can see here our curve shape here. So we fill this in, we can draw it like this, and continue up in this direction as well. Y is equal to x squared plus 2x minus 3. So continuing for our next one, we fill in our table of values. We've got minus 8, minus 2, 2, 4, and 4. So here we know, okay, our y, we put 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and minus 8 is just off the bottom here. And here, minus 1, minus 2, 1, 2. So when x is minus 2, y is minus 8, just off the bottom here. When x is minus 1, y is minus 2 here. It's a bit hard to see with our labeling, but it goes there. When x is 0, y is 2. When x is 1, y is 4. When x is 2, y is 4. And so this one looks a little bit odd here. And we can continue it on, but what we get is this shape, and here our curve goes just through there here. So here we have y is equal to 2 plus 3x minus x squared. Okay, so for our third parabola here, we fill in our table of values. We get minus 6, 0, 4, 6, 6. So here our y values, here y, and our x, we need to go minus 6 to positive 6. So 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, minus 1, minus 2. So when x is minus 2, y is minus 6. When x is minus 1, y is 0. When x is 0, y is 4. When x is 1, y is 6. When x is 2, y is 6. And we've got the same thing happening that we had with our previous curve here. Up, and it's going to be just above that 6, and then continue back down here. So we have y is equal to plus 3x minus x squared here. Okay, so now for our parabolas below, we want to show the following features here. So I'll just drag this down so we can see this better. We want to show the following basic set of features of a parabola, including our y-intercept, our x-intercept, our axis of symmetry, and our maximum and minimum values here. So here, our y-intercept is going to be 0. Our x-intercept is also going to be 0 here. So we can find our axis of symmetry is minus b on 2a. Here is going to be, b is nothing, so it's going to be our axis will be at x is equal to 0, and our minimum will be at that point x is equal to 0, and our y is also equal to 0 here. So here at 0 is pretty much all of our important information here. So our curve comes down through this point and back up here. So y is equal to 3x squared. So for our second line here, so we can change, we're going to make this x outside of x plus 1 here. So we can say, okay, well our y-intercept when x is 0, our y-intercept will be 0. And our x-intercepts, we can either have x is equal to 1, x is equal to 0 for our first part here, or x plus 1 is equal to 0, x is equal to minus 1 here. So our axis of symmetry here, our x is equal to minus b on 2a here, so minus 1 on 2, so our axis will be at negative a half, and our minimum so will be x is equal to a half, and our y will be equal to minus a half squared plus minus a half here, so it's going to be here a quarter minus a half and minus a quarter here. So we might draw this on a largish sort of scale so we can see this here. So we're going to have, here's our 0, we might have a half and 1, minus a half, minus 1, a half, 1, minus a half, minus 1 here. So here we have our y-intercept is at 0, and our x-intercepts are at 0 and minus 1. So here. So we know our curve goes through those 2 points here. Our axis of symmetry is at minus a half here. And our minimum point here is at minus a half here, and our y at minus a quarter. Be about there. So our curve goes down through minus 1 to this point, our minimum here, up through here, and out here. So y is equal to x squared plus x. So moving on from here, we'll just drag these up a little bit so we can see them a bit better, and we'll go through our processes here. So for our first equation here, our y-intercept is 3. So we can change our equation around. This is going to be x minus 3, x minus 1 here. So our x-intercept here will be at 1 and 3. Our axis is minus b minus minus 4 on 2a on 2. So it's going to be 4 on 2 is equal to 2, and our value at this point here, so it would be our minimum value here, when x is 2, y is equal to 2 squared minus 4 times 2 plus 3 is 4 minus 8 plus 3 here is equal to minus 1. So here we draw this onto our scale. We've got our x-intercepts at 1 and 3, so we're going to draw here 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on, minus 1, minus 2, minus 3, and so on. So here we've got our y-intercept is at 3. We cut through our y-axis at 3. Our x-intercepts are at 1 and at 3. Our axis of symmetry is at 2 here, so we know it's even about this point, and our y value for our minimum here is at minus 1. So here our curve goes down like this and back up here. So we have our curve y is equal to x squared minus 4x plus 3. So for our second equation here, we can see our y-intercept is here at minus 4. And we can break this up, so this one becomes x plus 4, x minus 4 here. So our x-intercepts are at minus 4 and 4. Our axis, we'll put it just over here so we can see here, our axis is minus b, there's no b, so we'll be at 0. And when x is 0, y is minus 4, so that will be our minimum point 0, minus 4 here. So we draw in our scale 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4 here. So here our y-intercept is at minus 4, so we're cutting through here at minus 4. Our x-intercepts are at minus 4 and 4 here. Our axis is here on y0, so our curve comes down like this here. So this is our parabola, y is equal to x squared minus 4.